All right, the last video I'm going to do is Newton's second law and free body diagrams. And these are just applying exactly what we're doing throughout this unit into a diagram that people can easily interpret. So the first thing that we're going to do is we're going to read the problem and break it down. I'm going to go ahead and zoom in so you guys can see exactly what this problem is saying. I would recommend following along with your own worksheet. All right, so an applied force of 50 newtons is used to accelerate an object to the right across a frictional surface. That's a lot, okay? So the first thing I would recommend doing is just drawing an object dot, okay? An applied force. So an applied force is saying I'm pushing or I'm pulling it. Applied force of 50 newtons is used to accelerate an object to the right. So right would be this way. You just write how much that force is. 50 newtons. And how we write this out is we know that's going to be a force. So we write force and then A for applied. If you'd like to write it out, you can. I'm going to use abbreviations. So we've got a 50 newtons applied force to the right. The object encounters 10 newtons of friction and is pulled by 73 newtons of gravitational pull. When you think of friction, think about sledding down a hill. When you are sledding down a hill, what is the friction doing? You are pushed down the sled. You're going down, going down, going down. And when you think of that as your applied force, then what happens down here? It pushes the opposite direction, okay? So you start up here, you're pushed, you've got an applied force, and then you slow down. This is because of friction, okay? And what friction is doing is it's going in the opposite direction. So this is the friction force, but the applied force is going down. So when I say the object encounters 10 newtons of friction, all you're going to do is draw the arrow the opposite direction and write 10 newtons, and you would write force with a little f for friction. Then it says, and it is pulled by 73 newtons of gravitational force. What does gravity allow us to do? If you jump out of a tree, are you going to stay in the air? No, you're going to go down. So what it's saying is you are going to have 73 newtons down. That's what's holding you on Earth. So 73 newtons, and then you can just say force of gravity. In your notes, we talked about normal force. Normal force is kind of bizarre and it's hard to imagine because it's not something we constantly think about, but it's what's pushing back up, okay? If you only had gravity pushing you down, you would keep going down to the core of the earth and you would burn alive. So what the normal force allows is this equilibrium, so then you're not continuing to go down, down, down. So if you jump out of a tree, you're not going to fall into the ground. You're going to fall onto the ground. So what this means is in order for you to actually stop, it has to be balanced. So you actually have a normal force, you have a force normal of that exact same number, so 73 newtons. So here's my question. If this object is going 50 newtons to the right and 10 newtons to the left, and we have an equilibrium, so we are flat on a surface and encountered some friction, is this object going to go more to the right or more to the left? It's going to go more to the right. And by how much? 40 newtons. Okay? So if we were trying to find the net force, remember that was that first worksheet with all of those different arrows on it. We're going to go more to the right, 10 to the left, and by how much? 50 minus 10 gives us 40 newtons. Okay? Next one. An applied force of 20 newtons is used to accelerate a 2 kilogram object to the right across a fictional surface. Sounds like a lot. First, draw a dot. Don't make it overly complicated. We've got an applied force, so we've got a push or a pull, and it's going to the right. So draw an arrow to the right, write 20 newtons, and we know that that is the applied force. And this object is 2 kilograms, so it might be helpful to go ahead and write that out because you may be solving a problem like this down the road. The object encounters 8 newtons of friction. Remember what that meant. The 8 newtons is going the opposite direction. So that friction is going to go the opposite direction, and that's going to be 8 newtons of friction force. Okay? The object encounters that, draw a free body diagram. Because I did not tell you the exact force of gravity, you actually don't have to draw that. So this is just fine. This is all you had to do for this problem. All right, I am going to go ahead and flip it to the back. And let's do these two problems together. So, an egg is falling from a tree in the nest. How sad. So, let's go ahead and draw a nest with an egg in it. Draw a cracked egg, it's going to fall. Neglect air resistance, so don't even worry about it. Draw the diagram forces acting on the egg as it's falling. Okay, well, we've got this tree, guys. It's a really beautiful tree. I know. We all want to live in it. This egg, we don't know if it was pushed or pulled. We don't know what the applied force is, but what do we know that the force is acting on? What's allowing it to fall? Why isn't it just staying in that place? What's allowing it to fall is gravity. So all you have to do is force gravity, and that's it. All right, last but not least, a rightward force is applied to a book in order to move it across the desk with a rightward acceleration. Diagram the forces acting on the book. All right, so we've got a book. Rightward force is applied to the book in order to move it across the desk towards the right. Okay, so we've got, this is the applied force. We don't know how much it is, but we know that's the applied force. Anytime there's a push or a pull. Move it across a desk. When you are sliding your hand across the desk, is there anything stopping you? Do your hands feel warm if you go like this? That's friction, okay? So there will be a friction force going backward, okay? Now, what's keeping that book from falling onto the ground? It's on a desk. We've got gravity. But why isn't that book continuing to go down to the earth, down the layers, and to the core? That normal force. So it would be force normal. That's it. Thanks, guys.